Okay, class, this is Chapter 10, Question 3, the example of the carpet shipping company. Imagine we have a carpet company that from each of 4 different factories wants to ship to each of 5 different distributors in thousands of rolls of carpet. So we've got some data in terms of cost of shipping. It costs $11 to ship from factory 1 to distributor 1, for example, $12 from factory 2 to distributor 1, and so on. We know that we have a limited capacity. Factory 1 has a capacity of 40,000, Factory 2 has a capacity of 50,000, and so on. Each distributor has a demand that they want. Distributor 1 wants 30,000, Distributor 2 wants 24,000. And we've got some space here to think through and come up with a solution. The same solver that we've been using throughout Chapter 9 can solve problems like this one. So we're going to go ahead and set up some of what we need. So we know we have to calculate out of our decision variables whether or not we're staying within the capacity constraints that were stipulated for us. So I'm going to go ahead and do a sum formula here. I'm going to go ahead and put in some dummy values in my decision variables so I can see if my formulas are doing correctly. Yep. So we're going to say that we're shipping the 5 out of each factory, 1 to each distributor. We're going to see what the demand supplied to each one is. So at the moment, with our dummy variables, we're only supplying 4 demand out of the 30 required to distributor 1. And we come on across. And what we want to do is we want to minimize the total cost of shipping. Now, we're going to use the sum product tool that we introduced in the prior chapter. The arrays are same shaped, so it's very easy to simply highlight one array, comma, highlight the next array, close the function. And right now it's $360,000 to ship 1,000 rolls of carpet to each of 5 different distributors from each of 4 different factories. Now, if we want to go ahead and meet this demand and stay within our capacity, we can go into Solver now. Go ahead and do my reset all. So in Solver, we know that we are trying to take the cost, minimize it by changing the variables. In all of these decision cells, how many are we going to ship from and to each location? And we have a few constraints. We know that our shipped capacity must be less than or equal to our stipulated maximum capacity. We know that our shipped demand should be greater than or equal to our requested demand from each distributor. And we're going to add one more here. So in distribution models like this and assignment models that are larger arrays, Solver can attempt to come up with solutions that have negative values. So we're going to add the non-negative stipulation by highlighting our decision variables array and putting in a greater than or equals to 0 requirement. So we've got those 3 added. We're going to go ahead and solve. Solver comes up with a very nice solution for us here. That does show that, yep, we met our 30, 24, 42, and 36 demand from the first 4 distributors. Yep, we stayed within our production capacity. So this seems to make sense to us at $2.66 million. So it looks like a good solution.